In class 12th, I am telling about the conversion of galvanometer into ammeter. The galvanometer cannot be used to measure the high currents because of the two factors. That is, when the high currents are passed through it, then it may damage the coil, and second, the pointer may break due to the high deflection. The galvanometer cannot measure high currents due to following two reasons. Number one, the high current will produce heat energy, large amount of heat energy, which may damage the coil. So H is proportional to I square. This is now higher the current, higher is the heat. You can see that if the current is doubled, the heat will be 4 times. It means that higher currents will produce the higher amount of the heat energy, and this will damage the coil. So coil may break. Now second, the large currents will produce a large diffraction, and as such the pointer will break So since in the galvanometer we are having the pointer that moves on the circular scale, so when the deflection is very large, then that moves very fast. So that will strike to the pin that is applied on the scale. So after striking to that one, this will break down. This will break. When it is strike, the stopping pin on the scale. So because of these two reasons, this galvanometer cannot be used directly for the measurement of the current. So about to this one, we apply a very low resistance in parallel with the ammeter, with the galvanometer. The galvanometer is converted into ammeter, converted into ammeter by applying a low resistance wire in parallel to coil of galvanometer. This low resistance wire, this low resistance is called shunt. So it means that the shunt is applied when resistance is low, then large amount of current will pass through the shunt and very small fraction will pass through the galvanometer. So that will not damage the coil. By connecting the shunt, the large current a large fraction of current will pass through shunt and the coil of galvanometer will remain safe. So what we have, let this is a galvanometer. This we apply a shunt. This is now shunt. S, let the current, this is now point A, this is now point B, then the current I passes through this one, then here the current will be this IS and here the current will be IG. So these currents will move like this, and at the point B, this is again the current equal to I. So this whole of this structure is called the galvanometer. It's called the ammeter. So let S equal to resistance of shunt and G equal to resistance of galvanometer. Galvanometer coil. Then the current. Then you can see that this by Ohm's law, what we have, this V is equal to Is into S equal to Ig into G. Current in the galvanometer is Ig and current in the shunt is equal to Is. So now we have this Is upon Ig equal to G upon S. So how much current will pass through this galvanometer coil? That you can have this Is upon Ig plus 1 equal to G upon S plus 1. So this is Is plus Ig upon Ig. This is equal to G plus S upon S. Is plus Ig, this is now I upon Ig equal to G plus S upon S. So I is equal to, now here this I equal to Ig plus Is. So I is equal to I into S upon S plus G. This so much. And now you are looking at S plus G is more than this S. Then definitely this Ig will be less than I. So this, since S plus G is greater than S, therefore this Ig will be less than I. So only so much fraction will pass through this coil, and now the scale is so calibrated that it always reads the actual value of current. The scale of ammeter is so calibrated that it reads actual value of current through the circuit. So now what we have that you can see from here that as this value shunt, the value of shunt is increased, this I will increase. So it means that to engage, to have the ammeters of very high range, the value of the shunt is always decreased. To make ammeters of high range, the value of shunt is increased. So now you can find that this I is the total current that is to be measured by this galvanometer. This is the full scale deflection current, and this is the current that is to be measured by the voltmeter, by the galvanometer, and then you can find the value of the shunt, that how much shunt should be applied, so that the galvanometer could be converted into the ammeter. The ammeter is connected in series in a circuit. This is never connected in parallel, because if this is connected in parallel, then resistance will again reduce. Because of that, the current maximum will pass through this galvanometer. So current passing through that the instrument that we are using for the measurement of some other value, that will be equal to 0. So there will be no current in the voltmeter, etc. So this is always connected in series in the circuit. तो अमीटर को हमेशा सर्किट में सीरीज में लगाया जाता है, इसको पैरेलल में कभी नहीं जोड़ते हैं। The ammeters of different range are made by shunt of different values. Now we'll find, if you want to find out the total resistance of this ammeter, then since the two resistances are in parallel, so we will have this 1 upon R equal to 1 upon G plus 1 upon S. The effective resistance of ammeter, this is equal to 1 upon R plus equal to 1 upon G plus 1 upon S, and this will give you R equal to G into S upon S plus G. S plus G. This is the effective resistance. So now what we do in this case, this is suppose This is like this. This is the coil. Here, this is we are having the soft iron cylinder connected to all these. These are the magnetic pole pieces N and S. Here we are having a spring, and here we have like that. This is not pivot. This is not pivot. Pivot. This is also, this is a spring. This is not pivot. And here we are having this is now terminal T1 and T2. This is now shunt, and here we have the this we can make to a more small part. This is pivot, and here we will have a scale like that. This is now suppose 0. This is suppose your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is now your 0.5, and the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is having the 1, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is coming out to be 1.5, 1.5. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is now your 2. This is now scale, and here we will have a pointer. This is not pointer. This is pointer. So this is the scale, and this we have the pointer. This is now pointer, and as this is now spring. So as the current is passed through this one, then it goes in this coil, and this is deflected, and then this is read on this scale that how much current is being passed in the circuit. So this whole arrangement is made in the non-magnetic box. This arrangement is made in a non-magnetic box having a glass window to see the deflection on the scale. So this is the ammeter. This is the conversion of galvanometer into ammeter. So different range ammeters can be prepared by applying the shunt of different values, and the scale is so calibrated that it always reads the actual value of the current passing through the circuit. So this is all about the ammeter. So ammeter is a low resistance device. Thus ammeter is a low resistance device. This is all about the ammeter. So thank you very much.